With previous maths lessons, we learned that Pythagoras' theorem could be used when you had a right-angled triangle and you wanted to find one of the sides and you knew the other two sides. Trigonometry is used also with right-angled triangles, but instead it's used for connecting the angles to the sides. So that in the trigonometry we will have equations that have angles in them as well as sides, not just sides like Pythagoras' theorem has. So where does it come from? Let's have a look. Here are two triangles that are similar. That means the angles inside are all the same. If I look at the one on the left, you'll see that there's a right angle there. On the one on the right, there's a right angle. There's a theta in this corner down here on the right-hand bottom corner of that triangle and a theta there. They're both the same angles. Because those two angles are the same, that means that this top angle, whatever it is, will be also the same. So in these two triangles, the angles are all the same, even though one triangle is bigger than the other one. These are called similar triangles, and we use similar triangles when we're using trigonometry. So now let's have a look at something that's similar about the triangles. If I take this side here 4 and this side here 5 and divide them, I'll get 4/5. If I take this side and this side for the other triangle, I'll get 8/10, which is actually also 4/5. So the ratio of 4 to 5 is the same as 8 to 10. Now, as well as that, 3 to 5 is also the same as 6 to 10. And also 8 to 6 is the same ratio as 4 to 3. So there are lots of common ratios within similar triangles, and we give them special names and use those ratios to help us work out answers. Unfortunately, the ratio depends on the size of the angles. Here are two different triangles with different angles. This one's got 30 degrees and 90. This one's got 45 degrees and 90. If I look at the two sides, 3 divided by 6 is a half. If I look at this one over here, which has got 45 degrees, 3 divided by 3, which are the two sides that correspond with the first triangle, that's not equal to a half anymore, it's equal to 1. So the answer that you get depends on the angle, and that's where trigonometry comes into its own. There are 3 different ratios that we use when we're doing trigonometry. We can have 3/6 using these two sides. We can have 5.19/6 using those two sides. And we can also have 3/5.9 or 5.19. That gives us 3 different ratios, and because of that we give them 3 different names. So we don't get confused, we use the same names all the time. Here is a right-angled triangle, and it has an angle theta. As it's a right-angled triangle, and the right angle's here, this long side is of course called the hypotenuse, and that's the same as what we'd call it when we're doing Pythagoras. The other two sides have the symbols or the labels called opposite, O for opposite, and A for adjacent. Adjacent means next to, so next to the angle, and opposite means opposite from the angle, away from it, not next to it. So here are some triangles, and we're just going to practice labelling the triangle. First of all, I'm going to identify the right angles in all the triangles, and you can see that that's not too difficult to find. When I'm looking to see the hypotenuse, it's always the longest side. So there's the hypotenuse for that one, hypotenuse, 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 hypotenuse. And you'll notice that it's always furthest away from the right angle. Also, it doesn't touch or doesn't connect with the right angle in any way. The right angle's over here, and the hypotenuse is not touching at any place. If I'm looking for the adjacent side, it is always next to the angle. So let's do the adjacent side. There's the adjacent side there, 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 and opposite side is the one that is not next to the angle, so the opposite side is here, 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 and here. Labelling the triangle is the first part of doing trigonometry. Because there are three ratios that we can use when doing trigonometry, they have three names. And to help us remember it, here is a simple saying. I like to think of it as a famous word, SOHCAHTOA. It helps you remember the rules. So you can see S goes with O and H, C goes with A and H, T goes with O and A, and here are the rules written underneath. The sine of the angle theta is equal to O over H. This word is spelt S-I-N here and on your calculators, but it's pronounced sine. The second one is cosine of theta is equal to A over H, and it really is spelt cosine. And the last one is tangent. Tan theta is O over A. So sine theta is O over H, cos theta is A over H, and tan theta is O over A. There are the three rules that we can use in trigonometry, and you'll notice that they've all got sides in them and an angle.